Today's lesson is called the limit. It's the very first topic of the calculus. The concept of limit is approaching to something. So let's pretend that we have a graph of a parabola. And we're trying to see what happens to the graph as you approach to this x value. So this value right here. So as the graph approaches towards that, you're going to approach this numerical value called f of x. And the concept of this graph approaching towards this value or the point is known as the limit. And here's how the notation looks like. And you read it as the limit of f of x as x approaches a. A will represent certain value on the x-axis. F of x will be your graph. So let's look at example 1 to figure out how to solve this limits algebraically. So our goal is to figure out limit of x plus 5 as x approaches 2. So there are multiple ways of calculating the limits. Again, we talked about limit is approaching to the value. So one way of doing it is creating an x and y table. And getting the value that is closer to 2. So let's say we have 2 over here. We could get 1, 1.5, 2.5, and 3. And we could observe how the graph behave as you get closer and closer to 2. So at 1, you have a value of 6. At 1.5, you have a value of 6.5. At 3, you have 8. At 2.5, you have 7.5. To see something getting closer and closer and closer and closer, technically you're supposed to have a smaller and small number that it'll be closer to the value that you want to find. So you could add on 1.99, 1.99999, or 2.1111, 2.0001. And this concept is known as Tabula Method. You're using the table to figure out the limits. Eventually, you'll find that you're approaching to the value called number 7. So the very first rule of calculating the limits is known as direct substitution. All you're doing is the value that you're approaching, you're substituting into the equation. So in this case, you're substituting 2 into the x, which comes out to be 7. But you get the same answer. So our next example, example 2, it says limit of x squared plus 15x plus 56 over x plus 7 as x approaches negative 7. So the first rule was to direct substitute. So we're going to substitute the negative 7 into the x. And let's see what we get as the answer. So this will be 49. This will be 105 plus 56 over 0. So this will result in 0 over 0, and we call that an indeterminate form. So basically, it means that we cannot determine whether you're dividing it by 0 or you don't have anything to divide it to. So we don't know the answer will come out to be 0 or the answer will come out to be undefined. We cannot determine it. That's why it's called indeterminate form. So if you have an indeterminate form, direct substitution obviously doesn't work. So what we're going to do is we're going to try to simplify this equation such that maybe direct substitution will work. And in this case, it seems like the numerator is factorable. So we're going to try to factor the numerator first. So this will become limit as x plus 7 times x plus 8 over x plus 7. And you're still approaching negative 7. So it seems like x plus 7 will divide each other out. So you're left with limit of x plus 8 as x approaches negative 7. So now we have a new equation, the simplified version. So we're going to go back to the step 1, which is the direct substitution, and substitute negative 7 in as x, which you get the answer of 1. So we could say that limit of x squared plus 15x plus 56 over x plus 7 as x approaches negative 7 will result in 1. So example 3, we have limit of 2x to the third plus 6x squared minus 5x minus 15 over x plus 3 as x approaches negative 3. So from the first example, again, we talked about the first step should be direct substitution. So it should be 2 times negative 3 to the third plus 6 times negative 3 squared times negative 5 times negative 3 minus 15 over x plus 3. So this will come out to be negative 54 plus 54, could be 9 times 6. This will be positive 15, and you have minus 15 over negative 3 plus 3, which means you get 0 over 0, which again we talked about. This is called indeterminate form. So once the direct substitution doesn't work, we say we're gonna simplify this equation. So if you simplify this, you'll get limit of 2x squared minus 5 times x plus 3 over x plus 3, and x is approaching to negative 3. So you'll find that these two will divide each other out. So you're basically solving for limit of 2x squared minus 5 as x approaches negative 3. So again, go back to direct substitution. So it'll be 2 times negative 3 to the second power minus 5. You get 2 times 9 minus 5 equal to 18 minus 5, which comes out to be 13 as your answer. So before we summarize the video, here's the question of the day. If you have a polynomial bigger than 4 terms, which method will help you to factor the polynomial? Just think about it. When you have 3 terms, we could do product with sum. If you have 4 terms, we could use factor by grouping. What happens if you have bigger than 4 terms, like 5 or 6 or 7 and so on? From today's lesson, we learned how to calculate the limits algebraically. First thing you want to do is to direct substitution. You want to substitute the value approaching to the equation. If that doesn't work, we're going to simplify. And one way of simplifying was factoring.